So we are live, and today in this video we are going to solve problems from MIT Integration B 2017, right? Yeah. So here are the problems from MIT Integration B 2017. So we'll solve these problems. I haven't really prepared for it, and we'll just solve together. We'll see how it goes. So first of all, let me see if we are live or not, and then we will begin. And you are encouraged to participate in the comment section so that we can do it together. I just don't want to do all of it on my own. I want it to be a bit collaborative. So yeah, first of all, let me see if we are live or not. There's no update. Okay, Mathless is what? Okay, it does show we are live, but wait, why cannot I access it? Just a second till I manage these things. Okay, so YouTube Mathless World. Okay, yeah, okay, it does show that I'm live. Okay, yeah, I'll just check the comment section too. Yeah. Okay, so yeah, we are live. Check the comment section too. Yeah. And now I think I should begin. Whenever you guys are here, yeah, definitely you can chat with me, right? Okay. So let us begin. So our first problem is integral of x squared divided by square root of x cubed plus 2. So integral of x squared divided by square root of x cubed plus 2 dx, right? Okay guys, now how do we solve this one? So for this one, notice that if I let the denominator as u, if I let that u is equals to x cubed plus 2, my du will just be 3x squared dx, right? So our x squared dx can be written as du by 3. So our x squared dx, that's in the numerator, can be written as du by 3. So now this will be helpful. Now since we know that x squared dx is just du by 3, and then square root of this is just u, right? So now we have 1 by 3 square root of u to the power 1 by 2 by du, and now we can just use power rule. So if we use that, this will just be u to the power 1 by 2 by 1 by 2 plus c. This 2 goes in the numerator, so 2 by 3 square root of u, where u is x cubed plus 2 plus c, and this is the answer. So this wasn't too hard, right? This was just a u substitution, and then we got the answer. 2 by 3 square root of x cubed plus 2. Let's check the answer. 2 by 3 square root of x cubed plus 2. Yeah, that's the answer. Now let's go to the next one. Integral from 1 to infinity log x by x squared dx. Okay, next problem is integral from 1 to infinity log x by x squared dx. Okay guys, now how do you think we should solve this problem? Again, what I feel is I can write this as log x by x times 1 by x dx, right? So if I make a substitution that u is log x, my du is going to be 1 by x dx. So this somehow simplifies. We don't know if this will really solve the problem or not, but this somehow simplifies the problem, right? So again, now I can write this as our u is log x, right? So if u is log x at 1, so at 1 the u will be log of 1, which is 0. At infinity, our u will be log of infinity, which is just infinity, right? So now I can say that in the world of u, this integral goes from 0 to infinity, log x becomes u, and x will now become e to the power u, right? So x will now become e to the power u, and 1 by x dx is just du. So now I think that this integral can be solved using integration by parts, right? I can just say that this is our first component, this is our second component. Now we know that, like, if we use integration by parts of u b is just u integral of b minus integral of derivative of u integral of b, right? So we will use that. So this will become u integral of e to the power minus u is e to the power minus u by minus 1, right? Minus integral from 0 to infinity. Now derivative of u is just 1. Integral of e to the power minus u is just e to the power minus u by minus 1 du, right? Now again over here we have minus u e to the power minus u minus. Now for this one, again, if I integrate e to the power minus u, I'll just have e to the power minus u divided by minus 1, right? And there's already a minus 1. So this is our integral. And the limits was from 0 to infinity, right? For this entire thing. So now we have minus u e to the power minus u minus e to the power minus u going from 0 to infinity. At infinity, notice that over here u will go to infinity, but e to the power minus infinity will go to 0, right? Now in this case, for such expressions where there is doubt, you need to use limits. So we are trying to see at u goes to infinity, what is the value of e to the power minus u, right? Now I can write this as u divided by e to the power u. Now this is in infinity by infinity form, so I can use L'Hopital's rule. If I use L'Hopital's rule and differentiate both numerator and denominator, this will just be 1 by e to the power u, which is just 1 by e to the power infinity, which is just 0, right? So this is 0. So at infinity, now we know that this ambiguous expression is just 0 from the limits. This is also a good use of limits, guys. And minus e to the power minus infinity is just 0, right? And again, minus sign of the integral. Now at 0, this will just be negative 0, right? Because 0 times e to the power 1, 0 is just 0 times 1, which is 0. Minus, this will just be e to the power 0, which is 1, right? So this will be 1. And 1 is the answer, guys. So yeah, I think 1 is the answer. So let's check the answer. Yeah, this is 1, right, guys? So I also hope you understood how we solved it. Now let's go to the next problem. Integral of sec h x dx. Now 3 number, which is integral of sec h x dx. Okay, now how do we solve this? Integral of sec h x dx. Okay, so now for this one, guys, if any of you are watching, you can give the ideas. So I do know that this is just 1 by cos h x, right? dx. But, okay, now how do I make use of that? Any ideas? Any ideas how I can make use of this now? Maybe I can introduce cos h square x minus cos h square x minus sec h square x in denominator, right? Or okay, what I can also do is I can change this cos h x as cos h square x by 2 plus sin h square x by 2, right? And in numerator also I can write 1 as cos h square x by 2 minus sin h square x by 2, right? Now if I divide numerator and denominator, divide numerator and denominator by cos h square x by 2. Now let's see what I'm gonna get. So if I do that, I will get basically. Hey guys, I don't need to change the numerator actually. Let me not change the numerator. Let me just let it be 1 itself. Just 1. Now if I divide by cos h square x by 2, what I will get is sec h square x by 2 divided by 1 plus tan h square x by 2. dx, right? Okay, so now if I let y as tan as x by 2, we know that dy is just sec h square x by 2 times 1 by 2 times dx, right? So 2 times dy will just be sec h square x by 2 dx. Now if I use this will be integral of 2 dy divided by 1 plus y squares. And now it's easy. Now it's just 2 times tan inverse y plus c. And again, we know that y is just tan as x by 2. So 2 tan inverse tan as x by 2. And this is the solution. Now let's see what's given over here. What's our solution from the MIT integration B? Okay, here it's given 2 tan inverse of e to the power x, right? So let's try to take it to that thing. Let's try to make it same. So they have their solution is 2 tan inverse e to the power x plus c, right? 2 tan inverse e to the power x plus c. Okay, now let's try to take it to that form. For that, let's try to modify this answer that we have got. So 2 tan inverse, now tan as x by 2 is e to the power x by 2 minus e to the power minus x by 2 by e to the power x by 2 plus e to the power x by minus x by 2 plus c, right? Now for this, what can I do? What can I actually do, huh? Okay. If I just multiply numerator and denominator by e to the power x by 2, what I will get is, I don't know if I'm in the direction of answer or not, but I'm definitely doing a good thing, I guess. I don't know. So if I multiply numerator and denominator by e to the power x by 2, I will get e to the power x minus 1 by e to the power x plus 1 plus c, right? How do I make use of this now? How do I even make use of this? Guys, if you have any idea, please let me know. How do I get this answer? 2 tan inverse of e to the power x, right? Okay. What kind of modifications can I make here for this one? Guys, I don't really see any ideas to make it happen. Okay guys, so if I cannot change this to this one, let's try to change this to this one. Okay, let me try to change this one to this thing. Okay. Okay, so let's say if C was 2 tan inverse minus 1 plus C2, then I guess we know that tan inverse A plus tan inverse B is just tan inverse of A plus B by 1 minus AB, right? So if I use that, this will be 2 tan inverse A plus B by 1 minus AB plus C2. So this is 2 tan inverse e to the power x minus 1 by 1 plus e to the power x. So guys, it's finally proved. So this is 2 tan inverse e to the power x minus 1 by e to the power x plus 1 plus c. So guys, we proved that those answers were same. So even though we couldn't go from this one to this one, we went from the given answer to our answer. So that proves that our answer was correct. Now let's go to phone number, guys. Let's go to phone number, okay? Let's go to phone number. Now phone number is, what's our phone number? Let's see. Integral of x cube e to the power x squared dx. Integral of x cube e to the power x squared dx. Now here also I think the good way is to first of all write it as x squared e to the power x squared times x dx, because now the reason I did this is, now if I let y as x square, now dy will just be 2x dx, right? So I can write this as y to the power y times dy by 2, and then I can write it as half times y to the power y dy, right? Now half times, now its integral will be, okay, so if you use UB rule, first of all u will be as it is. Now integral of e to the power is u, y is just to the power y, minus integral of derivative of y is 1, integral of e to the power y to the power y dy, right? And half, this is y to the power y minus e to the power y plus c. We know that y is x square, so this will just be, half of x square e to the power x square minus e to the power x square plus c. Okay, so this is it. Okay, so this is it. Sound is fine. Why aren't people watching this? Maybe I should have used mic, because the sound of the pen is disturbing me. Okay, let me do that. That can be okay. So otherwise people should have come, right? Well, I'll just introduce this mic over here. Is it resumed? Okay, yeah, I guess it has. Is it a new video or is it the same? I think it's the same. Yeah, I guess it has. Is it a new video or is it the same? I think it's the same. Now for this, what can I do? Okay. So now I don't think there will also be the disturbance from the pain, right? Also be the disturbance from the pain, right? Also be the disturbance from the pain, right? Okay, yeah, okay, fine. Now let me begin. Okay, so where I was. So okay, let's get back to the video now that I'm using a mic now. So we have done phone number, right? Now let's go to 5 number. Five number is about integral from 1 to 2, 1 by x square root of x square minus 1 dx, right? So this is integral from 1 to 2, 1 by x square root of x square minus 1 dx. Okay, now let's try to solve this. So to solve this, what I can do is, okay, let us see what we can do to solve this problem. Okay, I think this problem is a good use of trig substitution, and of what kind? Basically for this one, if I use sec theta, right? If I use x as sec theta, this will just be tan theta, right? Yeah, and this will be sec theta, and yeah, I think this is a good one. This is a good use of this substitution, so that dx will just be sec theta tan theta d theta, right? Now this will just be, now what is sec inverse 1? Okay, now sec 0 is 1, so sec inverse 1 is just 0. And what is sec inverse 2? Sec inverse 2 is just sec inverse 2. I don't think there's anything for that. Okay, sec inverse 2. Now 1 by this is sec theta, this is tan theta, right? And dx is just sec theta tan theta d theta. This cancels out, so the answer is just 1 d theta. So therefore now 1 is just theta going from 0 to second base 2. So this is the second base 2, is it? Second base 2 minus 0, which is just second base 2, and that's the answer. So let's see if our answer is correct or not. It's not, guys, it's not. It's pi by 3. Oh yeah, but second base 2 is pi by 3, right, guys? I'm sorry. Second base 2 is just pi by 3. So yeah, that's right. Now let's go to the next question, right? Let's go to the next question now. Next question is integral from 1 to infinity dx by x times x square plus 1. Okay, 6 number is, this was 5, right? 6 is integral from 1 to infinity dx by x times x square plus 1. Was it that? Dx by x times, yeah, dx by x times x square plus 1. Now how do we solve this one? So to solve this one, first of all, let's break this into like partial fraction, right? So let's try to break it to partial fractions. So 1 by x square plus 1, I can break it into a by x plus bx plus c by x square plus 1, right? Now this will just be 1 by x times x square plus 1, a times x square plus 1 plus bx plus c times x divided by x times x square plus 1, right? And they are just like same as being cancelled. Now over here I get 1 is equals to for x square the coefficient will be a plus b, right? And for x the coefficient will just be c, and for constant it will just be a, right? Yeah. And if you compare, now the constant should be 1, a should be 1 definitely, and c should be 0, and a plus b should be also be 0, so b is just negative a, which is negative 1. So we got it, right? Now let's try to break it into partial fractions. The integral will be integral from 1 to infinity 1 by x minus x by x square plus 1 dx. That is it, right? Now it's easy to integrate this because we know that now the integral will just be ln x minus half of ln of x square plus 1. This is going from 1 to infinity, right? Now first of all, let me write these ln's together. So this ln, if I write it together, that will just be x by square root of x square plus 1, right? Going from 1 to infinity. And at infinity, notice that this is an infinity by infinity form. Now let's try to see what's the value at x goes to infinity of x by square root of x square plus 1. Now what you can actually do is to find this, just divide numerator and denominator by x. So this will just be 1 by 1 plus 1 by x square. Now substitute x as infinity, so this will just be 1 plus 0, which is just 1. So at infinity, this is just 1, so ln of 1. At 1, this is just 1 by square root of 2. So this is just 0, and if you make it plus, it will be ln of square root 2. And now if I take the square root 2, because ln, in ln the powers go in front, right? So this will just be half ln 2. This will just be ln 2 by 2, right? Okay, let's go to the next problem now. And like like two of you who again he also left 7 number. Let's try to do 7 number now. Guys, and whoever you are watching, you can just like comment the ideas to me so that I can use it. Why do you leave so early? Integral of cosine inverse x dx, right? 7 number, we have integral of cosine inverse x dx. Okay, now for this one, how will you integrate this? A good way would be to use the integration by parts. Let 1 be u and this be v. Then we will have x. No, sorry. I just said opposite. Let this be u and 1 be v. Then this will just be cosine inverse x times x minus integral of its derivative will just be minus 1 by square root of 1 minus x square times integral of 1 is just x dx, right? Now this is x cosine inverse x. If I just take minus 1 by 2, if I just make it half, this will be minus 2x by square root of 1 minus x square dx. Now we know that the derivative of 1 minus x square is just 2x minus 2x, right? So if I want to do one thing, if I just write this 2 inside, so this will just like 1 by 2 root u du, right? And we know that the integral of 1 by 2 root u is just root u, right? So this will just be x cosine inverse x minus square root of 1 minus x square plus c. And that's the answer. X cosine inverse x minus square root of, oh wow, x square minus 1. Oh, yes. For cos inverse, it's 1 minus x square. Since it's cosine, it would be x square minus 1. I forgot that. This is x square minus 1 actually. X square minus 1. If it was cos, then 1 minus x square. If it's cosine, then x square minus 1. Okay, now let's go to the next problem again. 8 number. Phew, guys, you are enjoying it, right? What is it literally watching? Minus infinity to infinity, e to the power minus 2x square minus 5x minus 3. Good. We'll just do it. It's fun, right? Doesn't matter who is watching or not. Integral from minus infinity to infinity, e to the power minus 2x square, e to the power minus 2x square. And hey, one of you who is watching right now, can you suggest a solution for this problem? Problem 8. Minus infinity to infinity, e to the power minus 2x square minus 5x minus 3. So how will you solve this problem, man? Or girl, whoever you are. Can you suggest a solution for this one? Oh, he left. Wow. Okay. Now let me see how I can do this. So what I can just do is, I can just take 2 common, and then this will be x square plus 5 by 2x plus 3 by 2 dx, right? Now I can try to complete the square, e to the power minus 2, this will be x square plus 5 by 2x. Now this will be 5 by 4 square minus 5 by 4 square plus 3 by 2 dx, right? This will be integral from minus infinity to infinity, e to the power minus 2 times, this will just be x plus 5 by 2 whole square minus 25 by 16 plus 3 by 2 dx, right? And now integral from minus infinity to infinity, e to the power minus 2 times x plus 5 by 2 square. Now this will just be 3 by 2 minus 25 by 16. So that means 16 times 24 minus 25 minus 1 by 16. Okay. So this is minus 1 by 16 dx, right? Now I can just take the constant. I can now break this as e to the power minus 2 x plus 5 by 2 whole square times e to the power 1 by 8, right? Now I can just take e to the power 1 by 8 out, and minus infinity to infinity, e to the power minus 2 x plus 5 by 2 whole square dx. Now you might know that from the Gaussian integral, if it's from minus infinity to infinity, e to the power a x plus c square dx, this will just be root pi. So using this, we get that it's 1 by 8 times root pi, and that is the answer. E to the power 1 by 8 times, oh wait, how is it root pi by 2? This is actually root pi by a, I guess, not just root pi. Okay, let's actually try to derive this, guys. Let's try to derive this. How we can derive it? To derive it, the only thing, we don't know this general form. I just tried to predict, but yeah, that didn't work. But we definitely know this simple form, which is basically the Gaussian integral. This one is definitely root pi, right? So you will try to use this. So first of all, if I make a substitution that u is equals to x plus 5 by 2, right? Then this will be e to the power 1 by a integral from minus infinity to infinity e to the power minus 2 u square du. No sense, right? Now if I try to make a substitution that, let's say, b is equals to root 2 u. If b is equals to root 2 u, then e to the power 1 by 8, again from minus infinity to infinity e to the power minus 2. Now u will just be b square by 2, right? And du will just be db by root 2. Oh, this is root a. I don't know, guys. Let's try to see. Now e to the power 1 by 8, this will just be 1 by root 2 integral from minus infinity to infinity e to the power minus b square db. Now this is definitely root pi, so e to the power 1 by 8 root 2, this is root pi. Oh, so this is 1 by 8 root pi by 2. Okay, that's the answer. Yeah, so this is root pi by a actually. So let's try to see. Yeah, e to the power, is it 1 by 8 or minus 1 by 8? 1 by 8 and then root pi by 2. So that's the answer, guys. Let's go to the next problem. Sine of root x dx, which is our 9 number. Okay. So in 9 number, we have sine of root x dx, its integral, right? In 9 number, we have integral of sine root x dx. So let's see how we do that. What you can just do is, you can make substitution that u is root x, and then u square will be x, and then 2u du will be dx, right? And then this will be sine of u dx will be 2u du. So 2 comes out, u times sine of u du. Now if you try to integrate this, 2 times u integral of sine u is minus cos u minus integral of 1 minus cos u du, right? So 2 times minus u cos u plus sine u plus c, and u is root x, so minus root 2 root x cos root x plus 2 sine root x plus c is the answer. Actually, no one is coming here. It's funny. Negative 2 root x cos root x plus sine root x. Okay. Anyway, we will try to finish this. Doesn't matter. We are already at the half, right? Okay. Let's go to 10 number. What's 10 number? Our 10 number, wow. 10 number is integral from 0 to infinity dx by x plus 1 by x square. This seems to be interesting. Okay. Now, how do you think we will solve this problem, huh? I have no clue right now, but let's see. Now, what can I do? Okay, I can write it like x square dx divided by x square plus 1 square, right? Now how can I write this as x square plus 1 minus 1 by x square plus 1 square dx, right? Then I can now write it as integral from 0 to infinity of I can write it as 1 by x square plus 1 minus 1 by x square plus 1 square dx, right? Now what can I do? This seems to be like, product rule to me. Oh, guys, wait. Mm. No, 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 nothing, nothing, nothing. No need to wait. Okay. How do I deal with this? Guys, give me some ideas. What do you think? I don't know. I don't know if it's right or wrong. Okay, now what do I do? How do I deal with this, guys? So one of you, two of you who are there, can you please suggest an idea? How do I deal with this now? The first one is easy. How do I deal with the second one? Can you give some ideas, guys? Like two of you were there. Why isn't anyone responding? I can you give ideas? Okay, no. Let me see if what can I do. Mm-hmm. Maybe I can use. So let us try to see what happens if I try to differentiate x times x square plus 1. Okay, so if I do this, first of all, when I differentiate x, this will just be 1 by x square plus 1. Now if I differentiate this other thing, this will just be minus 1 by x square plus 1 whole square times 2x. Wow, so that means this will just be 1 by x square plus 1 minus 2x square by x square plus 1 whole square. Guys, wait, what this tells me is 2x square by x square plus 1 whole square is just 1 by x square plus 1 minus the derivative of x by x square plus 1, right? I think I can make use of this now because I know that x square by x square plus 1 whole square is just half of 1 by x square plus 1 minus half of the derivative of x by x square plus 1. Now if I know this, what I can do is I can actually substitute this in the original integral, because original integral was also x square divided by x square plus 1 whole square, the same thing, right? So now I think I can substitute that over there. If I make that substitution, let me erase all of this nonsense. If I make that substitution, so it will just be integral from 0 to infinity of half of 1 by x square plus 1 minus half of the derivative of x by x square plus 1 dx, right? So if that's the case, this is just 1 by tan inverse x minus half of x by x square plus 1. So see, so easily solved. So sometimes we need to like make some observations only. Now this is going from 0 to infinity, so at infinity this is just half of pi by 2, that will be 0 minus at 0, this will be 0 minus 0, so this is just answer is just pi by 4. And this was a good problem actually, right? This was a good, because we actually invoked a different kind of technique in this problem than what we used to do regularly, right? This was a good one. So the answer is pi by 4. Yeah. Let's go to the next one. 2 plus x e to the power minus x by x cube. 11 number. And two of you who are watching, please give your ideas on this problem. This is an integral of, what was the problem? 2 plus x by e to the power minus x by x cube. 2 plus x e to the power minus x by x cube dx. Guys, two of you who are watching, please can you give me ideas how to solve this problem? So that I can use your ideas. Okay, no one. Even that person left. Awesome. Now let me say it myself. How can I solve this? Okay, so What can I do? Hmm. What can I do, guys, for this problem? Can you guys suggest me the solution? Guys, can you suggest me the solution? Mm-hmm. Is there no limits in integration? Okay. So let's just try to analyze. So this is 2 by x cube plus 1 by x square e to the power minus x dx, right? Okay, guys, I noticed something. That this thing is just the derivative, it's almost the derivative of this thing, right? So that means, okay, now if I try to break it, actually, this is just 1 by x square e to the power minus x plus 2 by x cube e to the power minus x dx, right? Now let's, if I now, okay, so how is this work? Okay, how does this even work? I mean, okay, now, oh wow, so now I can see this as, so 1 by x square, so I can see this as 1 by x square, and then the derivative of negative of e to the power negative x plus, now negative 2 by x cube, and then negative of e to the power negative x, and this is just basically the derivative of the, because also over here this related to x, right? Now guys, what I want to say here is, this is u and then derivative, again the derivative of u and then b without derivative, so the answer should be negative e to the power negative x by x square. I think that should be the answer, right? Yeah, negative e to the power negative x by x square. So the next one, dx divided by x times 1 minus x. Okay, integral from 0 to 1 dx divided by square root of x times 1 minus x. Okay, so how will you solve this problem, guys? How will you solve this problem? I think you can just complete the square in denominator and that will just solve it, right? I don't think there's a lot of thing to do in this problem. So integral from 0 to 1 dx by square root of x minus x square, right? Now I can make this as dx by square root of negative x square minus x, right? Now I can introduce the things that make it square root of negative of x square minus x plus 1 by 4 minus 1 by 4, right? And then I can write this as integral from, integral from 0 to 1 dx by square root of 1 by 4 minus x minus 1 by 2 whole square. So this will just be, this is half square minus x minus half square, right? So this is a square minus x square, so this will just be sine inverse x by a, sine inverse x by a from 0 to 1, right? And now this will become, this will become 8 1, that's just 0 minus sine inverse of 8 0, this is minus 1, and sine inverse of minus 1, okay, if I use that, it's odd, this will just be sine inverse of 1, which is pi by 2, and that should be the answer, right? This was a simple one. pi by, wait, pi by 2 is not the answer? How is pi by 2 not the answer, guys? Oh, even at 1, this will be sine inverse of 1 actually. This will just be sine inverse of 1. So this will actually be pi by 2 plus pi by 2, which is pi by 2 times 2, which is just pi. So pi is the answer, guys. Right? Okay. Let's go to the next problem now. Problem number 13. Are you excited, guys? Literally no one is. 13. So integral from 0 to infinity tan hx by e to the power x dx. Integral from 0 to infinity tan hx by e to the power x dx. Right? Okay, now let's see how to solve this one. Okay. Now to solve this one, what should I use? We know that tan hx. We know that. Okay, so we'll. I think we should use the definition of tan hx, right? So if I use that, this will just be integral from 0 to infinity. Definition of tan hx is just e to the power x minus e to the power minus x by e to the power x plus e to the power minus x, right? And then this is 1 by e to the power x dx. Yeah. Now I can just use the e to the power x to divide the numerator. How should I proceed? Okay, now what I can do is, let us say that this is 1 minus e to the power minus 2x by 1 plus e to the power minus 2x. What I did is just divided by e to the power x in both numerator and denominator. This is e to the power minus x dx. If I make substitution that y is equals to e to the power minus x now, this will just go from okay, wait, this will just go from 1 to 0, right? Yeah, 1 to 0, and this will just be 1 minus y square by 1 plus y square. Wow. And then this will just be minus dy, so this will go from 0 to 1, and then 1 minus y square by 1 plus y square dy. Now I can write this as integral from 0 to 1 negative of y square plus 1, and again, since I introduced this minus 1 myself, I need to write plus 1 and then plus 1, this original plus 1 by 1 plus y square dy. So now this will just be integral from 0 to 1 negative 1 by 2 divided by 1 plus y square dy, right? And this will just be negative y plus 2 tan inverse y going from 0 to 1. So this is just negative 1 plus 2 times pi by 4 minus negative 0 plus 2 times 0. So this is just pi by 2 minus 1, and that's the answer, guys. How did you like it? It was a good problem, right? It was a good problem, right? Pi by 2 minus 1. Yeah, let's go to next one. Integral from 0 to pi by 2 is square root of 1 plus sine x dx. Okay, 14 number. 14 number. Integral from 0 to pi by 2 of square root of 1 plus sine x dx. How do I solve this? I think to solve this, I can just change sine to cos, and then it will be easy because we have formula for 1 plus cos x, right? So let's try that. So integral from 0 to pi by 2 square root of 1 plus cosine of pi by 2 minus x dx, right? Now if I do that, I will just first of all make a substitution. If I just make a substitution that y is equals to pi by 2 minus y, this will again go from pi by 2 to 0, integral of 1 plus cos y, this will be minus dy, and again the limits will reflect, making it go from 0 to pi by 2 square root of 1 plus cos y dy. Now I can write 1 plus cos y as, you can write 1 plus cos y as 2 cos square y by 2, right? So now I can take root 2 outside, and this will just become integral from 0 to pi by 2 of cos y by 2 dy. Now this one is easy because we know that its integral is just sine, right? And also we need to take care of the half that's with the y. This will just be sine of y by 2 divided by 1 by 2, and going from 0 to pi by 2. So this will now be 2 root 2 sine of pi by 4 is just 1 by root 2 minus 0. So the answer is just 2. That is a good answer, right? That is a real nice answer. Did you like it? Two of you who are watching, did you like this answer? Guys, say yes. At least motivate me. So yeah, answer is 2. Now next one is a good problem, I guess. Next one seems to be a good problem. Yeah. And the next one is the next question. Okay, next one is question number 15. We need to find the limit n goes to infinity where of in, or what is it? Limit n goes to infinity of in where I1 is integral from 0 to 1 dx by 1 plus root x. So where I1 is integral from 0 to 1. What was the question? I'll just paste it actually. I think, but I cannot do that. I don't know. Can I do that? I don't know. So 0 to 1 dx by 1 plus root x, dx by 1 plus root x. Similarly, I2 is, what is I2? What is I2? Okay, dx by 1 plus 1 by 1 plus root x. Okay. 0 to 1 dx by 1 plus 1 by 1 plus root x. Similarly, I3 is integral from 0 to 1 dx by 1 plus 1 by 1 plus 1 by 1 plus root x. This is a good problem, right, guys? Two of you, are you interested for solution of this problem? And I think, can you also share me your ideas? How do you think you will solve the problem? Huh? I think it would be better if I just get your ideas and if I try your ideas. If you have any ideas, can you please share with us so that I can use? Okay. No response. It seems like there's no response. Then yeah. Okay, now how I would approach this problem is, I will first of all try to find a function for this one. Let's say there's a function f of x that represents 1 by 1 plus 1 by 1 plus 1 by 1 plus 1 by 1 plus goes on 1 by 1 plus root x. So let's say there's a function that represents this, right? Now if that is the case, we see that this function is just 1 by 1 plus the function itself, right? The function itself, because this is the same function because it's going to infinity, right? Now I can write this as the function plus function square x is equals to 1, right? So the function square plus function minus 1 is equals to 0. And now I can solve for that function. That function will just be, wow, minus b. That's going to be a number, I guess. Minus b plus minus square root of b square minus 4ac by 2a. So that thing is just a number, minus b plus minus square root of 5 by 2, and since this is definitely a positive thing, so I will just take the positive number. So this thing is just a positive number, minus 1 plus root 5 by 2, not the other one, right? Now using this, now let's try to find the integral. Integral of from 0 to 1 dx of that when n goes to infinity, right? So yeah, we have already made the n go to infinity. Now we'll try to find this. This is just 0 to 1 of minus 1 plus root 5 by 2 dx. So this is just minus 1 plus root 5 by 2 times x going from 0 to 1. So that's just minus 1 plus root 5 by 2. 1 minus 3. Do you think this is the answer? Let's see. Yeah, it's the answer. Root 5 minus 1 by 2. This worked. Right, guys? I hope you understood this, how this worked. This worked. This just worked, right? Okay. Now, let's go to the next one again. Let's go to next problem. Problem 16. Hey, one of you who is watching, are you enjoying this? If yes, you can say comment yes. 16. Integral from minus infinity to infinity sine square x plus pi by 4 by e to the power x square dx. Minus infinity to infinity, and then this is just sine square x plus pi by 4 by e to the power x square dx. How do we approach this problem, guys? Now, how do we approach this problem? Let's give you ideas. Give you ideas, guys. Okay, now let me see how I can actually. I don't know. I don't really know how to approach this one. There's sine square as well as e to the power x square. Okay. I have no idea how to do this. No idea. How do I approach this problem, guys? Can you guys give some ideas? Okay, let me think. Okay. I think what can be helpful is, I'll just take the answer before I solve it so that I may get some hints. Answer is root 5 by 2. Okay, I think what I can do is, let me just try to. Oh, I got the idea. Okay, so what I can do is, I can first of all try to break this sine square function as will that work? Okay, let me try to break this as half of 1 plus cos of 2x plus pi by 2, right? And so e to the power x square dx. Now I can write this as 1 by 2 integral from minus infinity to infinity e to the power minus x square dx, right? Plus half of integral from minus infinity to infinity. This will just be cos of pi by 2 plus 2x by e to the power x square dx. Now pi by 2 plus dx is just minus sine x, right? So half of this is just root pi now, plus half of this is just minus sine 2x by e to the power x square dx. And now since sine 2x is odd function but e to the power x square is even function, so odd function in a symmetric domain from minus a to a, that just goes to 0, right? Because this entire thing is odd function. So we have root pi by 2 plus 1 by 2 times 0. So this is just root pi by 2, and that's the answer. This looked complicated, but it was actually easy. Go to 17 number. So yeah, root pi by 2 minus infinity to infinity, 3x square x cube plus 1 whole square e to the power minus x to the power 6 minus 2x cube dx. Oh, that's so long. So minus infinity to infinity, 3x square x cube plus 1 whole square e to the power minus x to the power 6 minus 2x cube dx. Okay, how do we solve this problem? I'm just so tired, guys. Okay, so let's try to solve this. Okay, so for this one, integral from minus infinity to infinity, I can write this as e to the power there was 2x cube, right? Yeah. Okay, so minus x cube plus 2, right? And then x cube plus 1 whole square 3x squared dx. Now if I make a substitution that u is x cube plus 1, this will again go from minus infinity to infinity e to the power minus of u minus 1 u plus 1, this is u square, this is du, right? And now this is integral from minus infinity to infinity e to the power negative of u square minus 1 u square du. Now this will be e to the power plus 1 comes out, minus infinity e to the power u square times u square du, right? Now if I make a substitution again, that now what substitution do I make? How do I solve this? If I make a substitution that what do I even substitute, guys? Yeah, what do you recommend me? Okay, now how do I approach this? Now for this one, this isn't a hard problem. I can definitely do it using gamma function, right? But I'm just trying to think of an easier way. This is just an even function, right? So I can definitely write this as 2e times integral from 0 to even infinity to the power u square times u square du, right? Now how do I do it, guys? Two of you who are watching, give me some idea. How do I solve this integral now? From here. Okay, so now I can definitely go with the u substitution, and that can definitely solve it. Like go by going to the. And right now this integral seems to be diverging because it's going to infinity. Oh, The problem was this, there is a minus thing. Okay. Now let me just go with they will go with the gamma function and then we will solve this. So there's a minus. If I make substitution that like z is equals to u square, right? Now this will just be 2e times integral from 0 to infinity e to the power minus g, and the u square is just dg, and since u is equals to g to the power half, du will just be half g to the power minus half dg, right? Now so this will just be e integral from 0 to infinity e to the power minus g to the power half dg. Now so this is just e times gamma of 3 by 2. So e times gamma of 3 by 2 is root pi by 2. So answer is e root pi by 2. And that's the answer. Oh wow. Yeah, it's e root pi by 2. Let's go to the next one, guys. This is the interesting problem. Like two of you who are watching, this is the interesting problem. Integral from 0 to pi by 2 dx divided by 1 plus 10 to the power 2017x. Can you try this? 18 number. This is an interesting one. Integral from 0 to pi by 2 dx by 1 plus 10 to the power 2070x. I genuinely want you guys to try this problem on a 1, because this is one of the famous problems in the world of integration. And yeah, please try this and let me know how you guys approach it. Any idea? No? Guys, try to make a u substitution that, okay, let me share the idea. If you make a u substitution that u is pi by 2 minus x, then this will just be integral going from pi by 2 to 0, and dx will be minus du, and this will just now be tan of pi by 2 minus x is just cot x, so this will just be cot of 2017x, 2017 cot x to the power 2017. Now you can use the minus sign to reflect the limits of integral so that it goes from 0 to pi by 2, and now this will be du by 1 plus cot to the power 2017x, right? Now you can write cot to the power 2017 as integral from 0 to pi by 2 du 1 by 10 to the power 2017x, right? Now this goes to numerator, so this becomes integral from 0 to pi by 2 10 to the power 2017x by 10 to the power 2017x plus 1. Okay, so this should have been du actually, not x, because here x is pi by 2 minus u, so this should have been u. I'm sorry for writing x. Yeah, so this is just u, and this are also u, du. Now I can again write this integral in terms of x, because these variables are just dummy, right? I can just make a substitution u equals to x, let's say. So 10 to the power 2017x by 1 plus 10 to the power 2017x dx. Now notice that if this is I, this is also I, right? This final result is also I, right? And if I add these two integrals, I get 2i as, since the limits of integral are same and since denominator is also same, I can add numerators. So 1 plus 10 to the power 2017x, I am adding this one and this one, right? So divided by 1 plus 10 to the power 2017x, which is the denominator. Now that's just cancels and becomes 2i is equals to 0 to pi by 2 of 1 dx. So this is just pi by 2. So I becomes pi by 4. That was such a beautiful integral, right, guys? Yes. Let's go to the next one. 19 number. go to next one, 19 number. And now we have just two more to finish this. Though there wasn't a lot of participation today, but it's still. 19 number is e to the power 2x cos 3x dx. So this is a standard integral. E to the power 2x cos 3x dx. Okay, now for this one, the solution would just be, we know the formula, right? The formula for e to the power ax cos bx dx, this is just 1 by, wait, what's the formula? It's 1 by a square plus b square, or the square root of a square. I think it's a square plus b square. Integral of e to the power ax cos bx. Okay, so the formula is just okay, e to the power ax divided by a square plus b square, a cos bx plus b sin bx. So this is the formula, right, guys? Now if I use this formula again, directly solve it, so our answer would just be e to the power 2x divided by 2 square plus 3 square, 2 cos 3x plus 3 sin 3x, and that's the direct answer for this problem. So we solved it. Let's check the answer. E to the power 2x by 13, yeah, 3 sin 3x plus 2 cos 3x, that's the answer. Now there's just one more problem to finish, and we took around 72 minutes. That's a lot actually. Okay, now we had 20 number. Integral is integral of, wow, this is such a good one. Okay, so cos x to the power cos x plus 1 tan x 1 plus log cos x dx. Whoa. Integral of cos x to the power cos x to the power cos x plus 1 tan x 1 plus log cos x dx. As if you see like this, like, don't say that I saw the answer, but if I see like this, definitely one of the things that you want to do is try to see how would the derivative of cos x this would be, right? So you definitely want to observe that, right? So that you can make some inference, or you can like see if the answer, like how you need to tweak or turn the initial function to give this required integral, right? So you would be doing that. So if I do that, so let's see if I want to differentiate this. So I will just first of all take log on both sides. So this will just be cos x log of cos x. And now if I differentiate this, 1 by y dash is equals to minus sin x log cos x plus cos x by 1 by cos x times sin x, right? So y dash will just be cos x to the power cos x, and this will just be minus sin x log cos x, and that is just, this is minus sin x actually, right? Yeah, and that is minus sin x. So y dash is just cos x to the power cos x, and then we have a minus sign. Okay, minus sin x log cos x plus 1. Okay guys, does this minus sign really exist? I mean, should it exist? Okay, fine. Now, if I want to make it tan x, I should divide by cos x, right? And also, if I divide by cos x, I should multiply by cos x, right? So this will be cos x to the power cos x plus 1 and there's minus 10x, and this is log of cos x plus 1. So I see that if I make this substitution, y is equals to cos x to the power cos x, this entire thing over here will just be minus dy by dx, right? And then there's this dx. So this will just be minus dy, so the integral will just be minus y plus c. Then integral will just be minus cos x to the power cos x plus c, and that is the answer. Minus cos x to the power cos x plus c. Yeah. So guys, we have done all 20 problems of MIT integration B. Though there wasn't a lot of participation today, so those of you who are watching it in the video mode, not in the live mode, hope you guys will enjoy it. Yeah, basically I think it will help you in learning how to solve these integrals, these simple but tricky integrals. So that was it for today. Thanks for watching and look forward to seeing you in the upcoming videos too. Let me end the live now.